0.
Yeah, so let's begin. We'll be going through testing. Yeah, and we're going to use the book by Dave Thomas. Okay.
Pardon me, Frank. Are you part of Podi? You just said you're Frank.
Yeah, I'm part of Podi.
Okay.
Yeah, I'm part of Podi. I'm an intern at Podi.
Okay, fine.
Yeah.
You're also with Tracy?
Yeah.
Or Akwapo?
Yeah.
Okay.
Okay, so we have a module, like the table formatter. Then to import so we are okay. We are beginning from the testing. Okay. When we already use the XUnit framework to write tests for our issues tracker app, but the chapter only scratched the surface of Elixir testing. Let's dig deeper. So, testing comments. When I document my functions, I like to include examples of the function being used. Yeah, can't hear you. When I document my functions, I like to. Pardon?
I'm saying just go on. Huh?
Okay. I like to include examples of the function being used, comments saying things such as feed these arguments and you'll get this result. In the Elixir world, a common way to do this is to show the function being used in an IX session. Let's look at an example from our issues app, the table formatter. Formatter module defines a number of self-contained functions that we can document. Yeah, so here we have our module, table formatter. We are quoting the inner module, each map join and max. So the module doc, it takes a list of rows data where each row is a map and a list of headers, prints a table to std out of the data from each row identified by each header. That is, each header identifies a column and those columns are extracted and printed from the rows. We calculate the width of each column to fit the longest element in that column. Yeah, so here we have our function. Print table for columns takes in rows as the first argument, headers the second argument. Yeah, then we have a width. Data by columns because that column width equals to width of data by columns. Format that. Okay. So as you can see, that's a model doc. That documentation is explaining that the function below. Then we have another function here. That one is split into columns, given a list of rows where each row contains a key list of columns, returns a list containing lists of the data in each column. The headers parameter contains the list of columns to extract. So here we have an example. Yeah. That is a list. Can somebody tell us What this list? What will be the first, the head? What into? Yeah, okay. So the first element in this list, it will be a map. Yeah. Yeah, then the map will have keys A pointing to the value value 1, B value 2, C value 3. Then the second element is also another map. The first key A has value 4, the second key B 5, C 6, like that. Yeah, then we call the function split into columns. We give it that list, and then the headers. Yeah. So the function split into columns. For each of those headers, we have header A, B, and C. For each of the headers, it will for each of the headers. So, like for example, if our header A, then the rows, that is our first. Okay, I don't know how I can probably look at me IX. Okay, let's start an IX section, an IX session for that. So so here is our list. Yeah, I hope I have no syntax error. Hopefully. Nataka and find this specific. Okay, so that is our first element in that list. Then our second element. Yeah, so there is our list. The first element, the map, it has the keys A, B, C. Second element, I have the map A, B, and C. Yeah. So our function takes in rows. In this case, the rows. Okay, the rows is this list. Then the headers is another list containing A, B, and C. Yeah. So let's define a function. Let me also need a moment. Yeah. So for each of the headers, so like for A, then it will go into the rows. We have two rows in this case. The first one contains this first list, this first map. Second row contains this second map. Yeah. Then it will call the function printable for each of the rows. So let's see what this function printable does.
Okay, okay. I want just to say something. Just yeah. Okay. Am I being heard? Thank you very much for hearing me. So the issue is, okay, I think we're not supposed to be getting, okay, as much as I know it's important to know what the function is doing, but I think we're supposed to deduce what function is doing from the documentation and the examples there. So we're not supposed to go further into it as such, because unless we're understanding functions in this mob, I think it's not necessary as such. The only thing which is necessary is you can deduce what function is doing from the docs to understand how to test the function using docs and stuff like that, I think. Okay.
Okay, thank you for that. Okay, so we're mainly going through the documentation and the testing for the functions. So as you can see, for this function split into columns, we have the documentation up there, and there's also doc tests for the same. Yeah. We also have another documentation here for another function, printable. So it returns a binary version of our parameter, which is a string. Examples, yeah, you give it the argument A, it returns A, you give it 99, it returns 99 in a string. Then our other function, width of, given a list containing sublists, where each sublist contains the data for a column, return a list containing the maximum width of each column. So our data is a list. Then when you call that function, it will return a list containing the maximum. So the maximum width for the first list, that is Wombat. Yeah. So length 6. This other one, Mongoose length 8. So as you can see from the documentation, we can just deduce what the function is doing. Then we have another function, format 4. It returns a format string that had codes the width of a set of columns. So we put stroke between a column. So example, we have a list containing 5, 6, 99. When you call that function, that is expected output. Yeah, so it takes for that 5, it will add that sigil. Yeah, in the hyphen and 5, then add s. The same for 6, and separates them with the stroke. We have another documentation here, separator. Generate the line that goes below the column headings. It is a string of hyphens with a plus signs where the vertical bar between the columns goes. So if you have your width 5, 6, and 9, and you call that function with that width, it will return this output here. I don't know how to explain that.
A string.
Yeah, a string. That string. Then we have another function which, given a list containing rows of data and a list containing the header selectors and a format string, it writes the extracted data under control of the format string. So the function, we have no doc tests for that. So it puts in columns, data by columns, that. Yeah, okay. So these are some of the examples of documentation for functions. So note how some of the documentation contains sample IEX sessions. I like doing this. It helps people who come along later understand how to use my code. Yeah. So your documentation should contain the IEX sessions. Yeah, like these ones. Yeah.
Okay. Just to add on what Frank just said, as we were going through the. Am I audible? Can I be heard? I don't know. Huh? But
Yes.
Can I be
Yes,
heard?
we can hear you.
Okay, thank you very much, Kitty, for telling me that I can be heard. So, okay, as Frank has just said, if you look at the documentation, the docs, that's the function docs. Okay, from my conclusion, you can see that it's using the art doc. That's what we usually use to denote the module variables, right? So you can see that doc is just a module variable. It's a string, which I think contains an explanation. That string, the string in the upper part is containing an explanation. And then just after the explanation, you can see an example, an EX session example. So an EX sessions example, mostly functions, from my understanding, that can be corrected. Mostly the functions which we use as EX session examples are usually functions which are pure, right? They have the pure, I mean, their results can be predicted, right? And then on the lower bit of the function, just okay, that's another story though. But you can see that function docs has an explanation than an IX example, that is. So generally, that's what we can deduce from docs testing. And then you can maybe have type specs after having the docs, yes, yeah. So it usually contain three parts. That's the explanation, and then the IEX section example, and then the doc type. So generally, it's just a variable, but it's a special variable in Elixir, in that Elixir recognizes it because it can compile it down to be there during the, what do we call that? Kizungu imepotea, during generating of documentation. Okay, it can be generated, yeah. Yeah.
Okay. Okay, anybody who has a question? Okay.
Unanisikia? Okay, so also for Obedo has mentioned about when you can use the IX session in your documentation. So I tend to believe that you can only use IX session when your functions are pure functions, they do not have any side effects. So for example, if your function expects either to return two options, you can't give it an IX session because it might not match. Yes, that's all.
Okay, thank you, Jackie, for that. So, anybody else with anything to add or a question? All right, so let's continue. So, but as importantly, it lets me understand what my code will feel like to use. I typically write these sample sessions before I start on the code, changing stuff around until the API feels right. But the problem in the comments is that they just don't get maintained. The code changes, the comment gets stale, and it becomes useless. Fortunately, XUnit has doc tests, a tool that extracts the IX sessions from your code's doc strings, runs it, and checks that the output agrees with the comment. To invoke it, simply add one or more doc tests, then the module name, lines to your test files. You can add them to existing test files for a module, such as table formatter, or create a new test file just for them. That's what we'll do here. Let's create a new test file containing this. So our module is called doctests. Use XUnit. Then we have a doc test here. So whenever you want to test your doc test, you will run mix test and then the test file. Yeah. Okay. So whenever there's an error with the doc test, then I guess your test will fail. Yeah, as you can see for this line, I don't know where the error is here. Version of parameter. All right. So with this second example, the argument is 99 and it returns 99.0, which will not be the case. So if you run the doc test, yeah, then this is the error that you'll get. All right. So next we are going to how to structure your tests. So you'll often find yourself wanting to group your tests at a finer level than per module. For example, you might have multiple tests for a particular function or multiple functions that work on the same test data. X unit has you covered. Let's test this simple module. So we have our module stats. It has a function sum, count, and average. Then here are the tests. When you calculate sum, this is you expect that to be output and count. Okay. So we're not going to go through those tests. There are a couple of issues here. First, these tests only pass in a list of integers. Presumably, we'd want to test with floats too. So let's use the describe feature of X units to document that these are the integer versions of the test. So when we use describe, you can group these tests into one. So all these tests, they can only take in integers, a list containing integers, that is. Yeah. So we've grouped them with the describe macro. So if any of these fail, the messages will include. Oh, okay. So if you look at the first test, it calculates the sum. When you give it a list, the list contains 1, 3, 5, 7, and 9. Probably, okay, if you add these ones, 9 plus 7 plus 5, that is 8. Yeah, okay. You expect the result to be 25. Yeah, from this list. So if at all it doesn't add up to 25, then your test will fail. For the second test, it calculates the count. It counts the number of elements in that list. So if you have 6 elements and you're asserting that the list contains 5, then your test will fail in that case. Then you also have another one for testing the average. So it will find the average of the elements in that list. Yeah. But then we have grouped all of them under the describe function. Yeah. The describe macro. Yeah. So all these tests only takes in integers in that case. So a second issue with our tests is that we are duplicating the test data in each function. In this particular case, this is arguably not a major problem. There are times, however, where this data is complicated to create. So let's use the setup feature to move this code into a single place. While we are at it, we'll also put the expected answers into the setup. This means that if we decide to change the test data in the future, we'll find it all in one place. Okay, so we have a setup function. Okay, so when you use setup, you can reuse this variable. Setup is run every time you run your test. For each test, the setup is run. Yeah. So there we have our setup. We have a list, and we have the sum. We have the count. So now when we test the calculate sum, we pass in a fixture. So the fixture will be the output from the setup. Yeah. So, and it will be a map in this case. So when I say fixture.list, then it means I'm trying to get this element here. Our second.
This fixture is with some kind of let me say. So fixture. Is it an inbuilt stuff?
Okay, fixture is just a variable in that case. Yeah. Yeah, so we also have another test, calculates count. We pass it in the fixture. Then we call the function starts.count. You give it that list. You assert that it will be equals to this count here. Yeah, so this fixture is the output from the setup. It's usually a map. For the third test, also calculates average, fixture, assert. We give it that list, then you find the sum, you divide by the count. Yeah. So as you can see, with these tests, we have not actually declared the list every single time. We have put all of them in the setup function, the setup macro. Thank you again for that. Okay. So the setup function is invoked automatically before each test is run. There's also a setup call function that is invoked just once for the test run. Yeah. So the setup, but in this case we are using setup, not setup all. The setup function returns a keyword list of named test data. In testing circles, this data, which is used to drive test, is often called fixture. Yeah. Also, fixture is like a common name for that. This data is passed to our test as a second parameter following the test name. In my tests, I have called this parameter fixture. I then access the individual fields using the fixture.list syntax. In the code here, I passed a block to setup. You can also pass the name of a function as an atom. Okay. So you can also pass a function here, but you call it as an atom. Oh yeah, so the function name is an atom. In that case, if you're using a function. So inside the setup code, you can define callbacks using onExit. These will be invoked at the end of the test. They can be used to undo changes made by the test. There's a lot of depth in NextUnit. I'd recommend spending a little time in NextUnit docs. Yeah, so we haven't covered everything here. If you want more, you can probably check out NextUnit docs. Anybody with something to add up to that point? Oh, yeah. Oh, yeah, by the way. Oh, yeah. So fixture is a keyword list, not a map. Yeah. Anybody with anything? All right, so I guess there's nobody with anything. Let's continue. So next we are moving to property-based testing. When you use assertions, you work out ahead of time the result you expect your function to return. This is good, but it also has some limitations. In particular, any assumptions you made while writing the original code are likely to find their way into the tests too. A different approach is to consider the overall properties of the function you are testing For example, if your function converts a string to uppercase, then you can predict that whatever string you feed it, the length of the output will be the same as the length of the input, and any lowercase characters in the input will have been replaced by the uppercase counterpart. These are intrinsic properties of the function, and we can test them statistically by simply injecting a large number of different strings and verifying the results on the properties. If all the tests pass, we haven't proved the function is correct, although we have a lot of confidence it should be. But more importantly, if any of the tests fail, we found a boundary condition our function doesn't handle. And property-based testing is surprisingly good at finding these errors. Let's look again at our previous example. So we had these functions. Sum count computes the number, counts the number of elements that vals. Then average finds the average. So here are some simple properties we could test. The sum of a list containing a single value should be that value. So if you notice, we didn't cover this test in our previous test. Okay. Yeah. So like in the previous example, we were only testing that if you have a list of elements, then you find the sum, then the output will be that. The output of that function will be that sum. But in this case, you're trying to test the sum of a list. If that list contains only one element, then the sum should be that element in that case. Then we also have another one. The count function should never return a negative number. Yeah. If you multiply the results returned by count and average, it should equal the results returned by sum, allowing for a little rounding. Yeah, so these are some of the additional properties that we could check for in those tests. To test the properties, the framework needs to generate large numbers of sample values of the correct type. For the first test, for example, we need a bunch of numeric values. That's where the property testing libraries come in. There are a number of property-based testing libraries for Elixir, including one he wrote called Quixer. But here we'll be using a library called Stream Data. As Joseph Alim is one of the authors, I suspect it may well make its way into core Elixir one day. Okay, so I could write something like this. We have a check that all number that are real. I'll do that. Okay, maybe we'll see that later. There are two pieces of magic here. The first is the real function. This is a generator. So I guess this real function is one that is in the module, the stream data, comes in the stream data library. So there are two pieces of magic here. The first is the real function. This is a generator which will return real numbers. So real numbers in this case are numbers that are not negative or
I think they're just positive numbers.
or they don't contain floats. What are real numbers? Huh? 0 to 9. Okay. So real numbers are 0 to 9. 0 to 9. You might think from its name that this will try all real numbers, which could take some time, but it instead just iterates a given number of times, 100 by default. So let's call this first. You add stream data to a list of dependencies.
If I'm not, I stand corrected though. No, real numbers are numbers which are not like the square root of -1, right? That's not a real number. Because square root of -1 is I think it's I or J. I'm not certain, but that's not a real number. So the real number should be any number which is not complex number.
So is negative a real number?
Yeah, negative is a real number.
Okay.
Yeah. If I'm not wrong, but it's
We can't hear you, Frank.
Oh, sorry for that. So we are now using describe instead of tests. Huh? Oh, yeah, okay. We are using property instead of test. Now we are testing the property single element lists are their own sum. Okay. So we have this macro check. Then for all number, so this one will generate sample integer numbers. Then for each of those numbers, you need to assert that if you give it a list containing only that number, the result should be that number itself. So there we're only testing a single property. You're not testing like the whole thing. When you give it each element, like 5 elements, then the output will be the sum of that 5 elements. You'll see this looks a lot like regular tests. We have to include use xcheck at the top.
Also, something to add about property-based testing. Usually, you test using a random data. You don't use data that you know. So, like here, we're only randomizing integers. So whatever it is, that's what we use.
Right. Thank you, Paulette. Yeah. Okay. So you'll see this looks a lot like regular tests. We have to include use xcheck at the top to include the property test framework. Okay. So you need to include this one at the top of the test, at the top of the test framework. Okay. The actual test is in the property block. It has the check all block we saw earlier. Inside this, we have a test that asserts that the sum of a single of a list containing a single element is that element. Yeah. So when you run the test, yeah, okay, it runs normally as the normal test. So let's break the test just to see what a failure looks like. So now we are changing the output of the expected output. We are adding 1 to the expected output. So in this case, our test will fail. Yeah. So when you run the test, so this is the output that you'll get. Property starts on that list, are there on some. It failed with generated values after 0 successful runs. Yeah. Okay. Yeah.
There are things there where they write left and right.
Oh.
That's the actual error.
Oh, okay. So on this side, it got 0. Then on the other side, it got 1. Yeah. Now that you added 1, in this case, so 0 was the number in that list. Yeah. So when you find the sum of a list containing 0, you expect to get 0, but your output specified that it should be 0 plus 1. So that is why it failed. Let's fix the test and add tests.
Frank, actually, our expectation was 1, not 0. We were expecting 1, but we got 0.
Oh, yeah.
So that's what our expectation is. So our expectation is 1, and then 0 is the result. That was what we got. We expected to get 1 as our result, but we got 0.
Yeah. So on the right side, you put your expected value.
Yeah, that's what our expectation is.
Oh, yeah. Thank you for that. So we have another test, another property, count not negative, that is the description. So check all, then for L, and then it gives us a list of integers. You assert that if you count L, it should be greater or equal to 0. Oh yeah, so count cannot return anything less than 0. That is absurd if it returns negative. Another test, single element lists are their own sum. Yeah, so this one also generates random integers. Then it will test for each of those integers. Yeah, yeah. Then we have another one. Sum equals average times count. So it generates a list of integers, a certain delta. Who can tell us what this function does?
You can check in docs.
Yeah, we can check that.
So a certain delta.
The difference should be almost, if not.
I think it's an inbuilt function.
Yeah.
Kuna mtu amepata share screen?
Yeah.
Huh?
Yeah.
Can you share your screen?
Can I do what?
So
Share
what
your
is
screen.
Sigurd? What is this book?
It's called Programming in Elixir.
Huh?
Yeah.
Oh,
I thought you guys were looking at property-based. There's a book on property-based testing as well.
Oh,
You have it.
I think I have maybe a copy, but I thought like you guys were looking at it, but just realized it's programming in Elixir.
yeah.
Okay, cool.
Connection is good.
yeah, please go.
Yes, please.
Okay. So using the XUnit documentation to check what's the meaning of a certain delta. So from the definition, a certain delta taking value 1 as a first argument, value 2 as a second argument, a delta, and a message, which the default value is nil. It asserts that value 1 and value 2 differs by no more than the delta. So I think the delta could be the difference you thinking that value 1 and value 2 could be differ by. So this difference is inclusive. So the test will pass if the difference and the delta are equal. So we have provided an example. A certain delta, the first value is 1.1 and the second is 1.5 and the delta is 0.2. So at least the difference is not more than 0.2. We also have an example there, the second one. Value 1 is 10, 15, and the delta is 2. Yes. So I think that gives an overview of what a certain delta does.
Okay. So it means the two values should not be different by that given margin.
Yeah, more than that.
All right. Okay, so let's continue. So a certain delta, the first argument is the sum of that list L. Yeah, then the second argument starts count L. What does this do? Inafanya nini? Count times average. Yeah. But then, so if you give it to these two values, the difference should not be
I think
more
one
than
is getting sum, and the other one is getting the count
count
times
times
average.
average.
So generally, it's like, okay, giving an instance, let's say the sum is. See, the key you are hearing.
Almost hearing.
Okay. As long as you keep hearing, I believe everybody does.
Okay, so let's continue.
Get you hearing?
Yeah, and then that too.
Okay, thank you very much. So, like the sum, it's giving us the sum, right?
Yeah.
And then the count then times average. So, I believe you count the average gives you the sum. You know. So count times average gives you the sum. And then we have the sum. So delta, this number, this 1 into exponential, it's a very small number. So I'm assuming the difference should be negligible in that the difference between sum and sum times. I mean, count the average should not be there. There should be no difference. It should be the same. So that's that's what it's trying to test there.
Oh, okay. So let's continue. The two new tests use a different generator called list, generates a number of lists each containing 0 or more integers. Running this code is surprising. It fails. Okay. So here is our error. The X unit properties of error fail to generate values after port is successful. Arithmetic error. Not argument in. Yeah, that's error. So there are, I don't know, it was given a wrong argument. But why would it for this guy in the first place? Okay, let's continue and we'll find out. Anybody with an idea? Why it failed?
Maybe the list of integers generated an argument which the function didn't expect or didn't capture in its function.
Yeah, so integer negative. That is very low.
Because real numbers captures both negative, positive, whole, large numbers, small numbers.
Yeah.
I think we should probably look at. I think we should probably look at the function list of to know what it expects.
List of. Okay. It's different from this one. Okay. Can someone check that for us? Copy better. Check. But I don't think if it's different from this other one. List of integer. Okay.
What's the library for server which you're getting data from?
Stream data.
Stream data. Okay. So here.
Are you sharing a screen?
Okay. The function is list of. I can share my screen. Okay. So using stream data library. So we have two functions. There is list of arity1 and list of arity2. Okay. We are using arity1. So you give it the data, and then it generates a list where each value is generated by the given data. This is the same as calling list of 2 with an empty list as its options. Okay, so list of arity2, you give it the data and the options. It will generate list where each value is generated by the given data. So the output is a list where each value is generated by the given data. I think that's all it
Sorry,
explains.
what's the type of data?
Mhm. How do we confirm? Just a minute. I've just given the name data only. How can I check the type of data we give from the function definition?
Let me check juu kabisa.
Aha.
How they define your data types.
Mm. Mm. Types.
Yeah, types.
A.
An opaque type that represents stream data.
It's an opaque type that represents stream data generator that generates values of type A. But this is not the data they have given as the argument.
So type can be anything.
Yes,
Could be a
type can
float,
be anything.
integer.
Okay, my wild guess. Yes. So I think it's supposed to be a value, right?
A value of type.
Of type. Technically, I can say atom.
I don't think it can be. How can
Like
you
some
know it can be an atom?
a function apple for hex docs.
How can you can't generate multiple versions of an atom? Oh, okay. And the lab. I was saying it can't be an atom, but it could be an integer, float. Yeah, any other
It
type.
can be data type.
But it can't be an atom. Why should it be an atom? You can't generate various versions of an atom.
It can be any data type. So, with the exception of an atom.
I think so. Tomorrow.
Let me share my screen. Okay, so from the GitHub page, the function list of data, if you check at that type spec, it takes in anything. So I think because the type of data taken at the type spec is TA, and we checked that TA was what was it? Let me just go to the table of the page. Yeah, an opaque type that represents as the data generator that generates values of type A.
So type A.
Opaque type that represents stream data generator.
Okay.
That
So,
type.
I think it is like, because, but I still don't get it. Because if it was anything, it would have been anything is nature, right?
Yeah.
That's how we represent anything. And there's sometimes when you can only define your own data type, right?
Yeah.
Not as like you can take a variable and use it to represent a data type. But it must be a data type. You must represent it. That's what I'm trying to get from. That's what I'm saying. You're not going to get more from there. Right? Because I believe if it's anything, then maybe it's using it to represent the anything data type.
Yeah, probably. But I don't think it can be an atom. Yeah, so our time is up. Let's meet again. Yeah, anybody with any question? Or anybody that comment?
Katie,
Yes.
or how to improve this. Yeah. And I guess our meeting has just ended. We'll meet next time.
So anybody, Getty, I had you had some problem with the
Who me?
you had a problem with what we're doing Sahi. So I think if there's any suggestion on what we should do next time, and okay, the topic suggestion, what we can do to improve the mob and stuff.
I suggest we should look for something a little hands-on so that it cater for everyone here. Kuna advanced, alafu kuna beginners kama sisi. And then we can just do something like, yeah.
Something with? I didn't get you, I'm sorry.
I'm saying we can choose something hands-on that will cater for everyone. Maybe we look at the wrapper that we were working on. Yeah, Africa's Talking. I don't know if you guys were there. Last time we were working on an Elixir wrapper for Africa's Talking API. Anyone?
Yeah, I think I support what Getty has said. We kind of implemented most of the stuff, and maybe there's still room for improvement. I think we only implemented one or two things. We are remaining with about a bunch of stuff to do. So it offers like a good opportunity to just learn, especially for beginners all the way to even advanced guys.
I think that's a good suggestion, yeah, because okay, and so the reason why we did this is because we didn't want to catch anybody off guard, so that's why we did this for everybody to like. I know without much preparation, that is. So I think when that the following week, that is, or when will it be again? When will we have another meeting? Okay, next week we'll do the hands-on stuff, and yeah. So I think